Alright, so this is our sending circuit. For the microphone, we have a voltage divider set up, so 4.5 volts travels through the microphone to power it instead of 9 volts. After the sources, we have two capacitors, so DC current doesn't flow back into the source and harm them. Next, we have two resistors. Alright, so after our mixing circuit, we have our summing circuit. Our summing circuit is an op-amp with a negative feedback loop. This is done to boost the AC voltage because the voltage from the sources are very small. Alright, so after our summing circuit, we have our bias T. For our bias T, we have the AC input from the summing circuit and then the DC input from the battery. We have capacitors after the AC input so that the DC input from the battery does not travel back into our circuit. And for our DC input, we have the inductor here, so the AC from the op-amp does not travel into the battery. These two voltages combine and send out the laser. So now discussing the value of our components for our circuit. The two resistors we have by our sources are low resistance. This is because the input from the sources are very low, so you want the resistance value to be low too. For our summing circuit, our negative feedback resistor is very high. This allows for the resistance output from the op-amp to be larger. For our capacitors, we have them in parallel to increase the capacitance. This allows the AC voltage from the op-amp to more readily pass through. And then we have two resistors for our bias T because the input from the battery is 9 volts, but you only want 5 volts to travel through the laser.
Okay, so this is our receiving circuit. Here we have our photocell, and what that is used for, it receives the output from the laser and it converts it into a voltage and sends it into the circuit. Once that voltage goes through, we have a capacitor here to block out any DC current that may have come through. Once that happens, we have an op-amp, but this time we have it going through the positive terminal because the input is going to be much smaller than it needs to be, so this will increase it by like a large amount. Once it goes through that, we have another capacitor here and then another filter, or just a filter, and what that's used for is it'll block out any remaining DC current that may be left, and it'll also improve the quality of the sound. And then all that remaining will go into the speaker, and then we'll have audio.
Alright, so this is our actual circuit. This is our input for our battery. Over here, we have our mixing circuit. So this is our voltage divider that feeds 4.5 volts into the microphone. We have our two capacitors and two resistors leading into our summing circuit. This is our feedback resistor, which leads into our bias T with the two capacitors, the inductor, and then the DC voltage input. And all that leads with a resistor to the laser.
Okay, so this is our receiving circuit. Here's where we have our the input for the battery. This is the solar cell that receives the output from the laser, converts it back into a voltage, sends it in through here. We have the capacitor here to block out the DC current. And then we use the op-amp again, but we use the positive source so that it'll increase it at a larger rate. And then it goes through. We have another capacitor here to block out the DC current, and then a filter to block it out even more so. And then that'll increase the audio quality, which goes into the speaker and then makes noise and music.